Hi, Assalamualaikum and good day everyone. So this will be this topic is in PDE. We are still about PDE, partial differentiation. But if you still remember that what I was said before, we have two approach. Okay, we have analytical and also the numerical. So for analytical, we have finished it. Okay, we are done it before in previous week 12, week 13 and week 14. So now for this week we will enter the new approach. The another approach, which is numerical. Okay, numerical approach. So just to summarize what we have learned before in analytical. So in analytical, we have one method which is we call it as a separation of variable method. And they have a few steps that you need to do it, which is step 1, you need to make it the equation separable first, and then you solve the separated equation by using the Fourier series. Okay, but now for the numerical, okay, we have another approach. So means I can say that for this chapter 5 PDE, you have two method. Okay, the first one is a separable variable method. That one will be the in analytical approach, and the second one is we call it as finite difference method. Okay, so finite difference method. Okay, so finite difference methods is a numerical approach. So for in this video, I will explain first the introduction of the finite difference method. So then for example and so on, I will proceed with another video. So class, so we just focus on numerical. So because for analytical we have done it before, kita dah settle pun for analytical. So I just give you the explanation on the numerical approach. So jangan mix up, jangan confuse. It's still PDE, kita still dalam topik PDE, but now it's a solution with the numerical approach. Okay, so we use a numerical technique. So the numerical technique that we use is finite difference method to solve the PDE. So basically the idea of it, okay, dia tak ada Fourier series, tak ada. So personally for me, I prefer numerical approach. But you need to study and understand both. Okay, because maybe in final, saya tak sure final, it will ask you analytical or numerical. So maybe either one or maybe both. So you need to know both approach. So basically for the numerical is, what we do is, the idea behind the finite difference is, dia akan discrete, what you call the discrete mesh of discrete point. Kita akan cari point. So basically, okay, I just give you the rough idea. Okay, rough idea. Okay, so basically each point, what we do is we need to find the value for each point. Okay, so point. So then how to find the each point? Yes, we will apply the finite difference method lah. But the idea what I want to say here is to find the point. Dia bukan cari it's totally different lah. Totally different between the analytical approach, which is you need to make it separable equation, Fourier series and so on. With this method, it's totally different. Okay. So you have x and t. So t is stand for time, x is stand for space ataupun jarak. Okay, space, gap. So usually the gap here for x, we use h. Okay, we use h. Okay, this is x. Okay, and for t, the gap here is, or the step size. The step size. The correct word is step size. So the step size for x, we use h, and the gap or the step size for t, okay, we use k. Okay, so that's the idea of the finite difference method. Okay, then, okay class, okay, for this one you need to have you need to know the formula. Okay, we have forward difference. Okay, I just use just write for short difference, difference formula. And then we also have the central difference formula, and we also have the backward difference formula. Okay, they have two. Okay, the first one here is for ut lah. Okay, saya tulis ut je. Okay, ut and for us. So you know that for ut here means that is differentiate between with respect to t, and us here is differentiate with respect to x. So sama juga for the others. Okay, ut us. Okay, so ut means differentiate only once with respect to t. Us means you differentiate only once with respect to x. Okay, we have another one, the central difference formula. Okay, you can see we already have, okay, I just write 1, 2, 3, 4. You already have for the number 2 here, you have central difference. Number 4 also but central difference, but for this number 4 is a central difference for double. Okay, UTT and USS. Okay, these three from 1, 2, 3 is all, only for single. Okay, UT, US. But for number 4 here is the formula for double differentiation. Okay, so I will write the equation for each of it. So basically you have 8 formula. Okay, we start first with the forward. Okay, forward different formula for UT. Okay, for UT. Okay, maybe some of you will ask, kalau because before this I realized that ada yang tanya UT ni apa? Okay, UT is stand for du dt. Okay, so it's the same meaning. Okay, UT. T here is means that you differentiate u with respect to t. So this is how the notation lah. Okay, so when UT is okay u I j. Okay, I just write first. Okay, ui comma j plus 1 minus uij comma j divided by k. Alright class, so I explain now. Okay, this is t. Okay, this is t. So what is t? So is the vertical axis here lah. Okay, paksi yang ni lah menegak, which is y. Selalu kita buat di y kan. Okay, so that is t. Alright, so that's why you can see that the formula here is divided by k. Okay, because the step size for t here is k. Right, that was the first thing. Okay, now uij plus 1. Okay class, so okay, I is represent for x iteration. Iteration maksudnya perkiraan untuk setiap x tu. Macam daripada x, okay, the first ni we x1, this is x2, this is x3, this is x4. So you can see that x1, x2, x3, x4. So 1, 2, 3, 4 is we denote as I. Okay, I tu maksudnya nak tunjukkan to represent the movement of x. Okay, the increment, the increment for x. So x, I is for x, and j is for t. Okay, so okay, sini suppose at 0 kita start with at 0. Okay, okay, so at 0, so they're the same thing. So now this will also be t0. Okay, at 0 at t0, and this one is t1, t2, t3 and so on lah. So the number 0, 1, 2, 3 is the increment, right? So for t we use as j. Okay, okay, remember I is x, j is t. So class, since we do it for t, okay, ut here, that's why yang I mean the formula kat sini ui, j plus t. So j yang bertambah. Okay, j plus 1 because we do it for differentiation for t, and then minus uij. Okay, so fix lah. Okay, this is the formula for forward. Okay, forward ut. Okay, forward ut. Okay, how about forward us? Okay, if forward us, it means I plus 1. Okay, kalau tadi j yang plus 1, so now is I plus 1 j. J is remain as j lah. Yang plus 1 kat sini adalah I. Okay, because x yang move. And then minus uij. This one is remain uij. And then divide by h, divide by h. Okay, the step size here is h. Okay, so done. This is a for forward. Okay, for forward. So now we move to centered. Centered or central lah. Okay, it's the same thing. Central or centered. Okay, maksudnya sama. So for UT, okay, sama juga. I will remain as I. J will add 1 ataupun increase 1. And then minus, okay, kat sini ada changes. It will be UI J minus 1. Okay, J minus 1. Okay, J minus 1. And then divide by 2K. Okay, divide by 2K. Okay, so it's different from forward. Okay, forward tadi, yes, UIJ plus 1 minus UIJ divide by K. But now it's central. UIJ plus 1 minus UIJ minus 1 divide by 2K. So for US, so you just repeat the same thing, but now it will be I lah. I yang akan minus and add 1. Okay, 2I plus 1 comma J minus UI minus 1 comma J divided by 2H. Okay, now for backward. Okay, for backward, okay, UIJ. Okay, UIJ UIJ minus UIJ minus 1. And then divide by K. Okay, class, can you see the different, not different, the relation between forward, central and backward. If forward just now, we make it the increment on the first term. Okay, the first term. And then at the backward, the back term is remain as UIJ. And then now for backward, kalau kita tengok for backward, UIJ, okay, is because dia depan, which is the first term is forward, ataupun kita anggap dia forward lah, depan. So it's remain. We just change on the backward. Okay, so J minus 1. So for centered pula, okay, for centered is a combination for both forward and backward. Okay, so that's why UIJ plus 1 and minus UIJ minus 1 is combination for between forward and also backward. Okay, alright, so for backward, UX is UIJ minus UI minus 1J divided by H. Okay, so all these 6 formula is for single, for first order. Okay, first order. So now we go to the second order, UTT. Alright, so it will be, okay, UI J plus 1, and then, okay, this one minus 2 UIJ plus UI J minus 1. Okay, divide by K square. Alright, class, so it's still this, it still have an idea of in the like the first order, which is the first and the last will be the combination from the forward and backward. But now in the middle now will be minus 2 UIJ. Okay, kalau tadi for first order tak ada pun yang middle ni kan, but now is second order, the second order, so it's different. They have a minus 2I. Actually they have what you call the steps lah, how they get all this formula. But I think for you, you just use it. Okay, for our syllabus or for as an engineering student, you just accept. You just use the formula, not derive the formula. So the derivation is you can tak perlu lah. You tak perlu susah-susah nak fikir kenapa equation macam ni. You just accept and you use it. Okay, because the derivation is usually for mathematics students lah, student yang take mathematics course, not engineering course. Okay, so for engineering course, you just accept it. Okay, you accept this formula and then you apply. Okay, you apply this formula. So this is for UTT. For USS is I plus 1 comma J minus 2 UIJ plus UI minus 1J divided by H square. Okay. Okay, class, so I think I will stop the video here because this is the introduction of the numerical or the finite difference method. Okay, so later on I will give you example, okay, and then we will apply it and you will see how the process of this method. Alright, okay.